Good afternoon, everyone. I promised I would review the midterm questions, and that's what I'll do today. I will post your grades after this review, and I will offer you an opportunity to rewrite the midterm, but this is the last time I'm going to discuss midterm questions, because tomorrow we're going to begin Unit 4, all right? So, I hope you hear me. There are people watching, apparently. All right. Just say something. Let me know who's there. Okay. You can ask me questions in the chat. So I'm going to begin. This is the questions were randomized, and also the options were randomized. So it might look slightly different from what you saw. This is a relatively easy midterm compared to the ones you tried, and I really thought you might do better as a group, but it wasn't so well done. So that's why I'm going to offer the opportunity to rewrite it. The rewrite will be, I understand, we have holiday, but I'm going to leave the opportunity to rewrite it on Thursday. And that will be from 6 to 9 o'clock, and no exceptions. If you don't get on or you can't find a way to get on, you're gonna have to let me know right away. But otherwise, it'll be from 6 to 9 on Thursday. Okay, and tomorrow we're gonna meet for an hour, and we're gonna talk about probability. And then we're gonna meet also on Wednesday and Thursday. And then, like I said, the midterm will be for people who want it from 6 to 9, that rewrite. Okay, so let's try these problems. A researcher wishes to study how the height of children during early adolescence is affected by the number of cups of milk consumption. This should sound familiar. She plots the height of children in inches versus the number of cups of milk. So that means that height is X. Height is Y versus cups of milk is X. Okay, because it's always Y versus X. And she fits a least squares regression line. She computes the correlation coefficient, and it is 0.9. So the question is, what is the slope of the least squares regression line? Remembering the slope formula, slope is equal to risk, RSY over SX. We're given information on R. R is 0.9. Why it's not sticking? Uh, 0.9. SY is 1.2. And SX is 3.6. And you put it all together, and what do you get? What do you get? going to get 0.3. The answer, and you can see that here, because this is like 0.9 divided by 3, so it's 0.3. So the answer is 0.3. All right? So that's that. Next. The 5-number summary is a data set, of a data set is given. If we were to construct the outlier box plot, which of the values 13 and 75 would be labeled as outliers? So remembering that what we need to compute are the thresholds on either side. So we're going to need to find Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR, just to be sure that there's nothing on either side, okay, because we're going to check both sides, the lower end here and the upper end over there. So what's IQR? IQR is Q3, which is this one, 52, minus Q1, which is this one. You subtract them, and you get 18. And now you want to use 1.5 times 18. So that's 1.5 18, which is 18 plus 9, which is 27. So now we're going to subtract 27 from Q1. This is going to be the lower limit. And then we're going to add 27 to 52. And that would be the upper limit. And what do we get? So you have 7. And for the upper limit, it's 79. So at 7 and 79, numbers lower than 7 are outliers. Numbers lower than 7 are outliers. And numbers for 79, numbers higher than 79 are outliers. So since neither of these numbers are outside of that range, 13 is not lower than 7, and 75 is not higher than 79. There are none, okay? So that's neither. Next one. A golfer conducts a study to examine the effects of a brand of golf club. There's 3 brands, and brand of golf ball, there's 3 brands, on his shooting distance. For each shot, the golfer randomly chooses which combination of factor levels to use. He will take 5 shots using each of their treatments. So how many shots will the golfer take in total? So what you want, he's going to have 5 shots for each treatment. Remember the formula for treatments, the number of treatments is equal to the number of levels of factor 1 times the number of levels of factor 2, etc. But we just have 2 factors, so we're just going to multiply 3 times 3, which is 9. But then for each treatment we're going to repeat, it's going to be repeated 5 times, right? So the total shots will be 5 times 9, or 45. That's the answer. Okay. Let's see. What's next? Who's there? Who's watching? Okay, how does the mileage in an automobile affect its asking price? A sample of 22 cars of the same make, model, and year were located in the for sale section of several newspapers. In each case, the mileage on the car and the asking price were recorded. The least squares regression line was given. So there you have the least squares regression line, and you have R square. So you're told about R squared is 64.1%. What is the correct interpretation of the slope and the least squares regression line? No, the slope of the, okay, so the slope is here. And the way we interpret the slope is always to say, it's bigger. So the slope was equal to negative 0.11, and you could write that as negative 0.11 over 1, and where x is the mileage on the car. So for every unit, so for every additional mile on the car, the price goes down 11 cents, or this is in thousands, so that would be 0.11 thousandths dollars, or you just have to add 3 zeros, so I mean, yeah, 1, 2, 3, so it's $110. So for each mile, the price goes down $110. So which one says that? So when the car mileage increases, okay, the thousands of dollars, oh, it's in kilometers, sorry, mileage, I said miles. So for each 1,000 kilometers, the price goes down $110, or $0.11 thousand dollars. So for Yeah, so D is the answer. When the car mileage increases by 1,000 kilometers, that's what the 1 represents, we predict a decrease, that's the negative, of the asking price by $0.11 thousand. Very good. So D is the answer there. All right. So in 60 minutes, I have done 5 questions. It's like, yeah, 5 minutes a question, 3 minutes a question. Okay, let's keep going. All right, so now we're going to see the plot. The time plot below displays the number of points of a football team scored in their first 7 games in a season. The median number of points scored by the team in their first 7 games is. So for this problem, you have to pull up the image that I sent you, because somehow it didn't attach. I'm just gonna get it. This is for football. Okay. And so when I look at that image, I'll pull the image up here. So this is the image. And from this image, I estimate the data points. Now, I'm not supposed to go in the middle, so this is deceiving. If you're going to go like something like this, that's not going to give you the right answer. This is not a histogram. This is a time plot. So basically, I have to extract the data from here. I have to see these are just the observations taken, game 1, 2, 3, 4, and these are the values. Okay, so neither can I use this to get, like, this isn't a histogram either. So that's not what you're going to do. You're going to extract the values and then use them. So let's go do that. So let's take those values, which I already did. So it turns out they are 33, approximately, right? 33. I don't know. It's not reading. All right. Let me make this bigger. So 33, 28, 29, 48, 31, 15, 15 and 27. Okay, so these are the values. So I have extracted the values, but now what is the question? I want to calculate from here the median. The median means I have to put them in order first. So I have to put them in order. To put them in order, it's 15. And then 27. And then 28. And then 29. And 31. And 33. And 48. All right. So now what you need to do is find the middle. So there's 7. You can use 7 plus 1 divided by 2, which is the rule for finding the position of the median. That's going to be 4. So the fourth one, so this is the fourth observation. The fourth observation is 1, 2, 3, it's 29. So the answer is 29. So that's A. What's next? Sets of twins. Sets of twins were used in a study to investigate whether a fluoride mouthwash used after brushing teeth reduces cavities. From each set of twins, a member, okay, sorry, there's lots of typos in this question. A member was randomly selected to use the mouthwash. These 20 individuals used the mouthwash after each brushing for a 6-month period. The remaining 20 individuals, one from each set of twins, did not use the mouthwash. At the end of the 6-month period, the number of cavities were compared. This is an example of, you have to realize this is exactly the setup for match pairs. Match pairs, the perfect match pairs are in people and in human subjects is the twin study. Okay, that's a perfect match pair is the twin, forming a twin study. And so that's what it is. This is a match pair. That's the best answer. All right. What next? Okay, so the same question from before about the car. How does the mileage on an automobile affect its asking price? So this is the same question we saw before. I had to retype it. Okay, the question here is though, so it's the same setup. I didn't change any of the features of the problem. But the question is, one car with 101,000 kilometers is being sold for $8,000. What is the residual? Okay, so the units are the same. It's always 1,000 kilometers and $1,000. So all you have to worry about is the number in front. Okay, those are the same units for the problem. Remember, thousands of kilometers and thousands of dollars. So all we have to do is compute. Make this bigger. So we're going to compute the observed minus the predicted for y. Y observed minus y predicted for this situation. The observed y the observed y is given. Okay, so when you're calculating a residual, the observed x and y are given. This is the observed x, and this is the y, the price. So y observed is 8. For this x of 101. You can call it x observed if you like, just so you know we know to connect them. So then that's y observed. Y predicted, we don't have it, we have to calculate it. We calculate it using the formula. So for this x, the y predicted is going to be 22.04 minus 0.11 for this x, 101. And when you put it together, what do you get? I'm just verifying my answers. I get 1093. Right, 1093. My iPad. I'm not sure why that's happening. It's losing its sensitivity. 1093. Or is it the pen? 1093. So then I need to compute observed minus predicted. So going back to the original, y observed minus y predicted is equal to the observed value being 8. Oh, I have to go up. And the predicted value being 10.93. And so my answer is negative 2.93. Okay. I think my pen is leaking. I need to pause. My stylus is leaking all over the place and it's affecting the sensitivity of the pad. Okay, I'm gonna take a pause. Pause. Okay, I'm back. My pen is in the garbage. I'm gonna have to use my finger until I find another stylus. Okay. So, it's okay if you're late. I didn't give you much warning, but you can review this. I'm just going through the test, as I said at the beginning. I'm just gonna go through the test, and so you can review this on your own. I'm gonna post the grades for the test after this, and maybe I will be able to release the grade, like, you can see which ones you did wrong. I'll see if I can set that up, because I closed that for the time being, because I actually delivered the test to 2 other people outside of the time that you wrote the test. So most of you wrote the test. So okay, let's continue with this. So this was negative 2.93, which option was A. All right, so let's try the next one. Okay, now some normal. The normal distribution. What proportion of the area under the normal curve corresponds to this interval? Okay, so this is a straightforward type 1 problem. I'm going to enlargen this. So between negative 0.63 and 0.42. Oh, there's some delay in my finger. Okay. All right, so that was negative 0.63, so that is going to be about here. And what was the other one? .42. That's going to be on this side. 0.42. So I always say I like you to draw it out, so you have a rough idea. Once you've solved it, you can check back with your drawing, make sure it makes sense. So all I have to do is standardize the 2 values. Sorry, no, it's already standardized. I just have to look up in my table the 2 values, right? And subtract them, taking the larger one and subtracting off the smaller area. And let's see what I got for that. Those numbers. Okay, I have the larger one is .6628. And the smaller one is 2643. Right? And so I have to take the bigger one and subtract the smaller one, and when I do that, I get the answer . 3985. Is that 3985? Yeah. Okay, so that's E for that one. Remembering that your options, the options that the options and the questions were randomized for the exam. So this might look a little bit different. Oops. All right, so let's do the next one. We're on 9, so we're a third of the way through. A 4th grade teacher would like to study how her students learn best. She divides the 24 students into 3 groups of 8. The first group learns the next unit strictly from watching videos, the second from textbook, and the third from the teacher. She then tests the students on the unit and compares the scores. Which are the factors? Okay, so that basically she's testing teaching method. So that's the factor, and then she tries 3 different approaches. All right, so she's testing the factors being a teaching method, which is the question. And the levels of the factor are going to be the videos, textbook, and teacher. These are just levels. All right? So the answer was C in that one. Okay, next one. A university uses a grade point system with a maximum possible grade point of 4.5 for each course. Here are the connection, hey? Sorry, it's a little bit blurry now. It's not blurry. Okay, the university uses a grade point system with maximum possible grade point average of 4.5 for each course. The student is awarded the following number of grade points per credit hour for each of the possible grades. So, one year, a student took the following courses and received letter grades shown. All right, so let's just translate each of these letters into their point score. Okay, so then these are going to be like the score. So the scores. So this is B plus is 3.5. Let me make this bigger. So this is 3.5. Let me do this in black. So this is 3.5. My finger. And A plus is 4.5. A is 4. C is 2. And B is 3, I believe. Let's go back and check. Okay, so I've translated those there. All right, okay, so that's the information I need. Now, I want to get the GPA. So each one is a weighted average. I need to multiply the frequency, right, of the grade here. And I have to multiply it all the way down and then sum them. That's a weighted, well, that's just the total, and then I have to divide by the total credits. So the total credits are going to be 2 plus 3 plus 4, 5, and 6. Does it say at the top? Just checking. It doesn't say, so you should know to do that. All right, so we're going to use the frequencies. So the frequencies all right, so multiply these across, sum, and then take the total of those and divide that by the total number of credits. And the total number of credits are these. So that's going to be 5, that'll be 10, another 10, so it's 20 credits. All right, so that's how we'll figure this out. When you do all of that, you get two, 3.5. I'm just checking. I'm right here, I'm just checking my work. Okay, so I get, all right, so I get, for the total is 64. I guess I can make the calculation here. So it's going to be, the total is 64, the total credits is 20, so it works out to be, the first one, 3.225. That's A. Okay? Nobody's watching. There's only 2 of you. Does that mean I should stop? Caroline, you're still there? All right. There are 3 children in a room, 5, 6, and 7. If another 6-year-old child enters the room, then what will happen? Okay, so the average of the ages is 6, right? 6 is mean and the median anyway. So another person who's the average is going to step in the room. So that's not going to change the average. So that's the point about the average. The mean will stay the same. But when you think about the formula for the standard deviation, we did discuss a problem like this in one of the classes. It's an old exam problem. So it looks like, if I add another value, I'm going to add one more observation. In total, it's not going to add anything because the observation is equal to the mean. It's going to be 0. So I'm adding 0. But what does matter is that the n goes up. When the n goes up, the denominator goes up and the overall number goes down. So S will go down even though the total doesn't change. The average of the deviations from the mean goes down because this next one is not deviated from the mean. It's exactly the mean. All right, so the option for that choice, the mean age will stay the same, but the standard deviation will decrease. So I will choose B for that one. Let's see, number 12. The variable x follows a normal distribution with standard deviation 5. Now you want to find the mean. Okay, and I give you this other information about the percentile. So it's giving you information on the distribution, the normal distribution, but you're going to have to use the fact that the normal and the standard normal are spread out the same way, except rather than identifying the variable values, the distribution that's standard normals accounts for those as the deviations from the mean. Okay, so it recasts all the values of the distribution, the normal distribution, and interprets them as deviations from the mean. So to do this problem, this is what it's telling me. It's telling me I want to know how many standard deviations I'm away from the mean for 0.2236 to be below it. So I drew it like that because this number is less than 50%. So it has to be, and this arrow is to the left, so it's saying the area to the left of under the curve to the left of 8 is this. Now, I'm not putting 8 on here. This is the drawing for Z. I'm going to use that though, and I'm going to translate back to the variable that's normal. So this is just saying that I have to be Z standard deviations away to get 22.36 on the left. So this is the 22.36 percentile. So when I look that up, when I look that value up, I get negative 0.76. It's a negative, right? It has to be a negative. So this ends up being negative 0.76. So now that it's now that I know that, so that was like my first step. For the backward problem. Now that I know that, I'm 70.76 standard deviations below the mean. I can convert that into the variable that's normal. The way that I do that is I say x equals z standard deviations from the mean. X is 8, right? That's the problem that they gave me. That corresponds to 8. And z is negative point, according to my drawing, negative 0.76. Sigma is given as 5. And the mean is what I want. So when you unravel this and solve for the mean, you get the answer. The answer is 8 plus Oh, what's that? Um, 8 plus negative 0.76 times 5, which is 4.2. Is that one of the options? It is. It's A. Okay, so you have to unravel this. Oh no, maybe that's not correct. That's not 4.2 because I have to add it, not subtract it. Let me do that again. It's 11.8 is the answer. Yeah, it's E. That is not correct. The answer is E. Okay, so if you subtracted instead of added, you would have got the wrong answer. Next, let me save that. Okay, let's continue with, oops, closed on me. Okay, so now I want to go to the next one. Oops. Done quite a bit. Okay, we're halfway in pages, beyond half. Okay, so this one. So all these problems should be familiar because I did several problems like these, just change some of the words. Okay, professors of a first-year course at a large university have determined the means and standard deviation of courses for all students taking the courses. They are shown in the table below. It is known for that the distribution of scores is normal for each of the courses. And basically with all this information, the question is, which course did Jim do the best in relative to the other students? So what you have to do is standardize, okay? You need to standardize. You take each score and you standardize with the group score. So the economics group or the economics course information is used to standardize economics, and calculus information to standardize calculus, and so on. So when you do that, let's do them all. This is 74 and 9. So, oh my goodness, so sensitive. So you have to take 85 minus 74 divided by 9. It's 1.22. And do that all the way down. Okay, so all the way down, just looking at my notes. Do the same thing. You're going to find out that the highest one is calculus. History. So that's going to be with 71 and 5 here. So history was 82. Minus 71 divided by 5, which 82 minus 71 divided by 5 is 2.2. All right, that's going to end up being the highest. I'm not going to calculate them all. You can check them all, and it's going to be history. It's going to be the highest. Next. No comments, no questions? Scores on a state mathematics exam follow a normal distribution with a mean of 67% and standard deviation of 8.42%. Don't let those percentages throw you off. That's just the information. Those are the units for that problem. So rather than centimeters or rather than dollars, it's percentage. But the percentage here has to do with the units, not with the percentiles. Now this next percentage is a percentile. So what proportion of students scored higher? No, sorry, this is not a percentile either. It's just a score. What percentage of students scored higher than 68.8% on the exam? So yeah, I guess it's testing your clarity in distinguishing between the units for the problem and whether they're asking you about the backward problem or percentiles. So higher than 68.8% on the exam. Oh, sorry, let me clear that. What I want to do is just answer this question like a probability problem. A proportion of X that is higher than 68.8%. I can write it like that. Okay, it's just the percentage just represents the units for the problem. Let me make this bigger. I'm going to run out of space otherwise. So the probability that X is greater than 68.8 is equal to P, and I use standardize, is greater than 68.8 minus 67, what was it, 67 and 8.42. Divide by 8.42. So 68.8 minus 67 divided by 8.42 is 0.21 0.21. Z greater than 0.21. Draw a picture. 0.21 must be here, just a little bit over 0. And you want this side to answer the question, so you're going to have to calculate. You're going to look up this value in your table. And you can do this two ways. You can look up this value here in your table, and then the table would be giving you this value, and you have to subtract that answer from 1 to get the one we want. Or look up negative 0.2 in the table. When you look up negative 0.2 in the table, you get the answer, which is 4168. Okay, so the answer is here. If you have questions, let me know. Okay, a variable x, next one. A variable x follows a normal distribution. Which of the following statements is false? All right, first, the area under the density curve must equal to 1. That is true, always. For any density curve, x equals x is 0 for all values of x. Remember, if for a continuous distribution or normal distribution, which is continuous, we only calculate the area or the proportion between values, not at one value. At one value, we say the probability is 0. It's so unlikely, we just say it's 0. Okay, to be precise. Standardizing x will give us the standard normal variable z. That's also true. If the mean is 100, then these should be equal. Well, in fact, these are equal distance from 110 and 90 are equal distance from 100. So because of the symmetry of a normal distribution, it's true that the area to the left of 110 and to the right of 90, they should be the same. So if I was to draw that, my pad is just, my tablet is not, it's just so sensitive. Okay, so if I'm going to be, let's say, I always say I don't like drawing the X drawings, but here it is. So let's say this was 100. It works in this case. And I'm at 110. So whatever, somewhere up here and equally back over here. So it's not to scale, but as long as I separate these two to make it look like they're evenly far away. So if I was to go this way and calculate the area all that way, it would be the same if I was to calculate the area all that way. And when I say all in that direction, I mean all this, okay? That will be the same as going this way. Of course, because of the symmetry, that's true. All right, so don't confuse that drawing, by the way, with talking about the area between. That's not what I'm saying. I'm saying this, let me do this one more time. I'm saying this is the same as this. If this is 90, and this is 110. Okay, those are the same areas. That's true in a normal distribution. And finally, the mean must be positive. There's no stipulation that for a normal distribution, a mean should be positive. This actually was poorly answered by you guys as a group, but that E is the right answer. The mean must be positive is wrong. This one is true. This one is false. There's no reason why the center has to be a positive value. Okay. This one is true. Okay. We have done, let's say, save that. Let's continue. We're almost done. This is a very easy test, I have to tell you, compared to the ones you were working on. So we have 6, 7, 8 now. Here we have 4 pages to go. Okay, the ages of a random sample of 62 audience members at a symphony are recorded and are represented below. These are the ages. Which of the following is false? Okay, so we made a frequency distribution. Hold on. I needed a break. I needed a water break. Okay, the ages of a random sample. Okay, so these are 62. Which of the following are false? Select one. The median age is in the 50 to 60 interval. Okay, where's the median? Let's go each one at a time. The median for 62 people, the median should be found at 62 I don't know why my tablet is so sensitive, not sensitive. 62 plus 1 divided by 2 position, right? So it's going to be 31.5. So between 31 and 32. So looking back, between 31 and 32, well, let's add up this. Let's do this cumulatively, right? Cumulatively. The first observation is 1. But then we have, this will bring us to 4th observation. And then the next 7 will make it 11. And then the next 10 will make it 21. And then the next 16 will make it 37. And the next 21 will make it 58. And finally, we will have 62. So 31 and 32 will be found in this interval here. right? Because this ends at 37, this one ends at 21, so it's going to be in this one. So that's 50 to 60 interval. So that one is true. The first statement is true. Right? So the range of the data is greater than 50 years. The range of the data is greater than 50 years. Well, yeah, because you're going from age 10 to 80, possibly. So it's at least greater than 50. If this one ends, if everybody was 70 in this one, that's the minimum. So if you use the minimum and the maximum, let's use the minimum one here, the maximum one here, that's 50. So at least, you know, if everybody in here was 20, or this person was 20, and if everybody in here was the lowest end, 70, then you would have the range at least between 20 and 70, which is a range of 50. So this one is true. The data distribution is skewed left. Well, on a number line, if I was to rotate this, which actually I can do, interesting. So if I was to rotate this this way, you know, it's actually a few values on the left side, so it is skewed left, right? If you think about it that way, you know, most of the values, or the median we said was over here, and then you have just one value over here, and these kinds of it's very slightly skewed left, I'd say. It's not greatly. And there's a lot of values here, actually. So yeah, I guess this does peak out, and this goes like that. All right, let's put it back. Okay. So we will say it is true. It is not possible to calculate the exact value of the sample mean from this table. That is true, isn't it? Because I don't have the values. I just have the range of values. So it's going to be impossible to get the actual sample mean. I could estimate it, but not exactly compute it. The last one must be false. The first quartile of ages is in 30 to 40 interval. Okay, first quartile, remember, is 25% of the observations. 25% of 62 is what? That is the real question here. So 25%, which is the same as 1/4. iPad doesn't like when I expand it. It's the only way I can get things written very nicely. Oh, what is that? Go away, go away, go away. I don't want this thing. Oh, I pressed this by accident. Oh dear, dear, dear. Go away, this thing. I need to... Oh my goodness. What is this? Maybe I have to pause for technical difficulties. So wait, it's gone. Hope you're not getting dizzy. All right, so what was I doing? All right, I was calculating 25%, which is 1/4 of, which is multiply, 62. So what's 1/4 of 62? Or 0.25 of 62. That's 15.5. So 15 or 16 observations need to be in the first, right, so 25% of the observations is about 15. Okay, so at least 15 will be in the first quarter. So let's see, back to the distribution. So the first quartile of ages is in the 30 to 40 interval. Did I make a mistake now? 30 to 40 interval. Because this will be 15 and 16. So it should be in the first quartile, should be in the next one, because that will be 15. But we have to go, into this one here to capture 15.5 or 16. So this is a tricky one. So the definition of a percentile is the 25th percentile marks 25% of the observations being below it or at it. The fact that it's 15.5 observations pushes us into the higher interval. So E is false because it should be actually the 40 to 50th interval. Okay? I'm just confirming my calculations. Okay. Let's go on. A chef is trying to figure out the optimum way to cook a turkey so it doesn't dry out. He uses 3 temperature variations, 4 different cooking times, as well as 2 different weights of turkeys. 4 turkeys will be cooked at each combination of factor levels. How many treatments are there in this experiment? So what you have, we did this already. It's going to be 3 levels for the first one and 4 levels for the second one, and then 2 for the last one, so that's 12 times 2 is 24. 24 treatments. The next one is back to the car example. It's always the same one. Same setup, different questions. What is the correlation between car mileage and asking price? So you're given not the correlation, but you're given the coefficient of determination. That's this one here. So this is 64. So this is actually R square is 64.1%. Or we can write that as 0.641. So then we can get R by taking the square root of that. And when we take the square root of that, we get 0.80, and we have to tag on the negative. We did this in class because it's a downward sloping regression line. It's a negative trend, in other words. So because it's negative relationship, the answer is negative point. Well, I guess I can put a 101 in there. So the answer is A. So I guess the way it's showing, it's demonstrating, yeah, the answer is A. So save this. If I have the patience, I'll set up the timestamps for this so you don't have to watch the whole thing, just to check out the answer to one question. Oh, I'm doing this a long way. Okay. 2 more pages? 7, 8, 9, oh, 3 more pages. Gee. Oh, okay. Variable x follows the normal distribution with a mean of 2 and standard deviation 1. Okay, so you just draw this. And this time, because you're using the rule, you get to draw it with 68, 95, 99.7, like this. And with 2 in the middle, and standard deviation of 1, that means that 1 standard deviation from the mean puts you at 3 here, and 4, and 5. And then this way, it will put you at 1, 0, and negative 1 over here. All right, so if we want the area between 0 and 1, that means we're looking for this area here. Since we know between here and here is 95, and because we know this is 68, in other words, let me divide that. So it's 68 in the middle, but also 34 on each side, right? So I'm going to put 34. And then basically we're going to take 95 in half and then subtract off 34. That's my approach. So it's going to be, and I think we did this, I remember doing this problem. So we're going to do I just have to pause, let it get sensitive. So 95 divided by 2 minus 34 will give you your answer. And that works out to be Hey guys, I'm back. Crashed. My computer crashed. It's just the streaming is just too much for it. I'm going to continue, or should I start another video? I'm not sure. Or maybe just take a pause, because it's rather long. So maybe, well, let me just finish it here. Are you guys hearing me? It's running again. Catalin, are you there? So, oh. And there's that. All right. So the answer should be, whatever that is. It's 13.5. So the answer is E. Okay, the answer is E. Next. The municipal government in a city would like to know whether its citizens would support increased spending to improve the city's splash pads. A worker visits 3 splash pads in the neighborhood and interviews 5 parents. All right, so this is what? 3 splash. So the worker just shows up at the splash pad. There was no listing, labeling of like coding and labeling the subjects and any kind of randomization. So that leaves us with the convenience sample options A and C. And what do we suspect? We suspect that this will be biased towards people who use the splash pads, right? So this will overestimate the true proportion of citizens who support increased spending on splash pads, because people using it are more likely to support it. So the answer is D. Next. Let Z be a standard normal variable. What is the value of Z? Well, that's the backward problem. Testing that you know how to do this, how to draw this properly. Really? If you were to draw this, this takes a little while. Okay, so I want 9920, that's the amount, 9920 on the right. So remember, this says area under the curve to the right of Z. So Z must be over here, because to the right, to be so big as 0.9920, it's got to be a huge space. So the little z, that number of standard deviations away should be over here, should be a negative value. So be careful when you look this up in the table. What you're getting is, if you looked up this number in the table, you would be getting the positive version. You would be getting the value over here, right? But you want this one, the negative version. So when you do look this up, you get, let me see. I have to go to get it. Nine nine 20. When you look up 9920, it's 2.42 is the sorry, 2.41. So this is going to give you, if you look this number up, you're going to get 2.41, which is over here. But you should know the one that we want is the negative. The negative version of that. Okay? So, that's why you have to draw it, to be sure that you're not working on the wrong side. So we want negative 2.41 is the answer. Okay. 22, we're almost done. A group of students, oops, I don't know why it's doing that. A group of students who enrolled in an introductory statistics course were randomly assigned to take the web-based course or to take a traditional lecture course. The two methods were compared by giving the same final exam in both courses. A group of smokers and a group of non-smokers who visited a particular clinic were asked to come in for a physical exam every 5 years for the rest of their lives. So this one's a prospective study of smokers and non-smokers, and it's an observational study. There's no experimental treatment there. The first one, this is random assignment, so this is an experiment, right? With two methods. Okay, and the last one were compared with employees of the corporation to see if the CEOs were more likely to be the firstborn in their families than were other employees. First one is an experiment, and the last two are observational. So, yeah, the answer is A. All right. You're going to run a field experiment to investigate the effects of 4 fertilizers on the yield of wheat. You have 40 plots of land available and you wish to run a block design. So there's 40 plots of land. Now the idea here, the answer is going to be the one where all the treatments are performed in the block. That will be your correct answer. And the one for that, and it's not that the putting into the blocks is not random. The blocks are determined some way. And then inside of the block, the 4 treatments have to be randomly assigned to different groups that have been, the groups have been randomly determined and then the treatment applied within the block. So put the 40 plots of land into 10 blocks of 4 plots each, with the 4 plots within a block being as similar as possible. Then randomly assign the 4 fertilizers to the 4 plots within each block. Into 10 blocks of 4 plots each. So Put the 40 plots of land into 4 blocks of 10 plots each, with the 4 plots within a block, the 10 plots within a block being as similar as possible, and then randomly assign a fertilizer to each block. This is wrong, see, because the assignment should be within the blocks, not to each block, the assignment of the fertilizer. Randomly assign, so this is for sure not it. Randomly assign the 4 fertilizers to the 40 plots and then put them into 4. This is wrong too, because that's not how you do it. The blocks are determined first, then within the blocks the 4 treatments are applied. Randomly put the 40 plots of land into 10 blocks of 4 plots each, and then randomly assign the 4 fertilizer to the 4 plots within each block. Okay, so this is the best one, right? This is the best one. This one so far. D. So E, randomly put the 40 plots of land into 4 blocks of 10 plots each, and then randomly assign a fertilizer to each block. No, this is wrong. So anyone where it says randomly assign the treatments to the blocks, that's not correct. It's within the block. So this is my favorite answer, because you are going to, no, you're not going to randomly put them in. Sorry, that's not the best one. Let's go back. This one, where you put the 40 plots of land into 10 blocks, is better. Of 4 plots each, within 4 plots within a block being as similar as possible, then randomly assign the 4 fertilizer. This is the answer. This one is not the answer because the blocks are not assigned randomly. The blocks are some characteristic. There's a rationale for blocking, so there's a reason for blocking. You're putting them in the blocks in a certain way so that they have some predetermined characteristic that's going to make them distinct within the blocks from the other blocks. So, but if you put randomly put 40 plots of land into 10 blocks of 4 plots each, block should have been determined. Anyway, we can talk about that some more if you have some questions, but I prefer A as the answer. Okay, now we're going to go for the histogram, the drawing that I sent you. Let's pull that up. Let me save this. So this is the histogram. And what is the question? The question is, right, these are the salaries. So if you remember when we talked about income is usually considered skewed right? A few people make lots of money, but most people make about the same. So in terms of this problem, the histogram shows annual salaries of hockey players in 6 teams. To provide the best numerical description of the center and the spread of the distribution of the salaries, what should you do? In this case, it's skewed, right? So the best numerical description would be numerical is a 5-number summary. But you could argue it's a 5-number summary, but you could argue that quantile box plot also shows numbers. I mean, it's showing you the distribution, but it's considered a graph. I was very generous and I gave points for this one as well as a 5-number summary, but the 5-number summary is the one I was really after because it's a skewed distribution. We should be looking at the 5-number summary, okay? The length of TV commercials is known to follow a normal distribution with a mean of 30 and a standard deviation of 0.4. Find the 60th percentile of the distribution. So I want to find the 60th percentile and to do that I need to know how many standard deviations I'm going to be away to be at the 60th percentile, right? So what would that be? So to be 60%, and remember when we draw this we use the Z. So this is a backward problem because I'm giving you the percentage and you're going to tell me about the length of a commercial. Okay, so this is a backward problem, and I'm going to start with step 1 is to use the standard normal to learn where relative to the mean is the 60th percentile. So 60% is like over here because middle is 50, so I'm just going to be over here to make 60. So what is the Z that's going to do that for me? What's the Z score that's going to do that? Oops. What is... Oh my gosh, I lose everything when I do that, don't I? So what's the Z that's going to give me that is the question. I'm just going to put this here. For 60%. And I put 4 decimal places because that reminds me to go inside the table. So looking inside the table for 60%, it should be close to 0. The best answer I come up with is 0.25. So this needs to be 0.25. So I'm going to be at 0.25 standard deviations from the mean to be the 60th percentile. So I need to translate that in my second step. So I say X standard deviation, X is what I'm looking for, is equal to Z standard deviations from the mean. So Z is 0.25. Standard deviations, go back to see what that is 4, and the mean was 30. So this is going to be 4, and the mean was 30. So it's 31. Is the answer for that one. Okay. If two quantitative variables x and y have a strong linear relationship, then which is the right answer. The value of the correlation must be positive, not necessarily. It could be strongly correlated negatively. So this is not right. There is evidence that X causes. Nothing with the word causes is acceptable when you're talking about correlation. Oh wait, it has to be one of these has to be right. Wait, there might not be any causal relationship. This one is wrong and this one is wrong. So it has to be this one because there might not be any causal relationship between X and Y. There might not be any causal relationship. Of course there might not be any causal relationship. It could just be an association. This is an example of when we discuss the relationship between variables that have an underlying or lurking variable behind them that affect them or impact them in the same way. Okay, so they might not be caused, one might not cause the other, but because they react to another underlying variable similarly, it looks like their association, people would speculate that one does cause the other, but logically we argue that, for instance, a person, on a beach population is not going to be more likely to drown because the residents are eating ice cream. Remember that example. Okay, so that even though they're strong, linear, and there's a strong linear relationship, it doesn't mean that one causes the other. That was what I wanted to get at. Okay, so just one more page. If you've hung in there all this time, thank you for being my audience. If you haven't, you're just watching it now. Thanks for hanging in and watching the whole thing. Okay, the last two problems. Drugs are often used for reducing the blood pressure of hypertensive patients. Those with high blood pressure, an experiment was run to investigate the effect of drug A or B and dose level on the reduction in blood pressure. The experiment was conducted separately for 36 patients who had mild hypertension and 24 who had severe hypertension. Okay, so what was the design here? So we're going to test two factors. The effect of a drug and the dose level of the drug. So there's two factors with two levels each. But we conducted the separately, we analyzed the mild hypertensive people with the severe so ones with high blood pressure and low blood pressure were separated by a block. It doesn't say the word there, but that's the idea. They were given the treatments separately. So there's two factors, drug and dose, and there's one block. So the answer there is B. And finally, the distribution was for 42 men. The first quartile of heights is in which interval? Too many of these quartile questions. I hope you managed to get through them. Okay, so there's 42, and 1/4 of 42 is 1.05. So 10.5 is 42. Is that correct? Yeah, so just double checking what I'm doing. Okay, so that means that the first quartile should end including the 10th observation and maybe the 11th observation. So that's going to, so we'll say the 10th and the 11th observation, right? Because it's 10.5. So that means that if we do the same thing that we did before with the cumulative, this will bring us 1, this will be up to 4, this will be 7 observations, this will be 11. So there, it has to be in the 6 to 68th interval, because that's where the 10th and the 11th will fall. So that is the answer. So that's it. We did this. We did this in 2 hours with a lot of technical issues. So this was a doable exam. I will write you a message to remind you that you will have an opportunity to rewrite it on Thursday. Also, if you want to rewrite the quizzes, you have an opportunity for that on Thursday. And I'll leave those both open. And anyway, I'll see you tomorrow. Tomorrow I'm going to start the probability unit, unit 4. Okay, so have that available. I'm going to teach 1 hour, 5 to 6 every day. You don't have to attend, but please watch the videos within the day. I guess Thursday I should have a class at 5 as well. And Friday. I'm going to put them up. I know it's a holiday. Again, you don't have to be there, but I need to accumulate the videos for your sake. Okay, well, talk to you tomorrow. Have a good night. Bye.